Well, good afternoon, everyone. I'm very happy to be here, and thank you, Jan, for the invitation. As I said, we are based in a very small town in Italy, in the north east part, where the point is, and me and my company, we've been engineering timber buildings for about 18 years. We started in 2003. And this gave us the opportunity to see kind of an evolution, but also a revolution in the timber industry. We started from a very small town in Italy, but then I said one day I said, why don't we see what is happening outside Italy, what is happening around the world? So this is actually the map with the projects we're working on. We recently added a nice project in Brazil, which will happen next year around June, July, and it's going to be one of the biggest freeform roof in the world, made of timber. We're talking about more than 1,700 square meters, many arches intersecting each other, and we are doing these projects. On every project, we always try to use the most advanced technologies, the most advanced tools on the market to always try to push the boundaries and find new ways to use timber. Our position in the market, just very quickly, something about the company is this position makes us in a quite unique situation because we are between the producers on one side. We work with and for producers, manufacturers of CLT, GLT, LVL, etc., all over the world. And on the other side, we work mainly with designers, which means architects and engineers, but we also work with general contractors, developers, and builders. So we can see we can have a very holistic approach to the design, and we can try always to value engineer every single project to reduce the cost and to make timber the most cost-effective material to use. Once my colleagues hate me because I arrive in the morning in the office and say, what about this? Why don't we try to collect some of the biggest projects or some of the nicest projects we work on? We try to collect them in just one single model. So we tried to do this a few months ago, and this is the result. We worked on many timber buildings on different scales, residential buildings, office buildings, and we are always very happy to see how timber can be used also in for different types of buildings. I always like to show this slide because this is made by the University of Graz in Austria, but it shows how the CLT production changed in the past 25 years. We are talking about a very young material in general. We are using timber, which is one of the oldest material used by the humankind to build homes. But look at what happened from 1995 to 2020. In 1995, the global production, the numbers you see here is how many cubic meters, how was the potential global production of CLT all over the world, how many cubic meters. So in 1995, the total potential production was about 25,000 cubic meters per year. 10 years later was about 100,000. 10 years later, 2015, was about 650,000 cubic meters per year. Then, in the past 5 years, the production almost doubled. Because now, 2021, probably I'm waiting for the new for a new version of the diagram, but they are already talking about 1.4, 1.45 millions of cubic meter per year. There are new CLT factories in the US, in Canada, in Russia, in Australia, New Zealand. So the market is really growing very fast when we talk about CLT. This shows that the industry, the timber industry, thinks that CLT can be the future of our buildings. We're talking more and more about sustainability. So this, in my opinion, this shows really how timber can help us to solve the problems. As I said, in the past 18 years, 17, 18 years, I think there was not only an evolution of the market, but we saw a revolution of the market. There was a digitization of the whole process. So now we are using technologies. It's very common to use technology like BIM, computational design, generative design, robotic prefabrications. We saw something beautiful. Sejai presented something very beautiful about prefabrication. We can also estimate the cost of a structure in a very precise way. And this allows us to make a very important process, which is the value engineering process, which is the stage of the project during which we can reduce the cost, we can optimize the material, and we can combine together different technologies. Personally, I'm a big fan of hybrid structure, which combines together timber, concrete, steel. In my opinion, we need to get the most out of each material, to use the right material in the right position. We also experimented, and I will show you later a couple of movies, how augmented reality can be used in timber, especially because everything is based on prefabrication, is based on a digital model on the computer, the digital model can be quite easily transformed to a file for the CNC machine. To do this, we need to have a holistic approach. And to show you what I mean for a holistic approach to design, I like to use this movie I took with a very small drone. If we need to raise our point of view, we need to have a global view of the project. We cannot stay just at 1 meter and think that we know everything about a building. We need to raise the point of view. As I said, here you see now that it is a multi-story timber building. You see what we have around the building. We can understand if we could have logistic problems, if it will be quite complicated to get there with the truck. Holistic approach means also to know a little bit about building physics, about fire, about acoustic, about how the element will be produced, how the element will be lifted and will be transported and then lifted on site. Having this approach, you as designer can value engineer the project, can make timber the good material to go for. What is missing here is the production. Where is the production? What do they do in the production? What do they do before you see this building? Just to give you an idea, to assemble those elements, it took about 1 week and a half. But before these 10 days, the working days on site, there were months, weeks of meetings, discussions among designers, owners of the buildings, etc. To better understand what production means and what the assembly on site means, we need to have a good idea of what DFMA stands for. It stands for Design for Manufacturing and Assembly. So timber means to know, timber engineering means to know how the elements, what happens in the production. How can we talk to the production? What do they need? What do they expect to get from us? What kind of drawings? What kind of files can we send them? What is possible to do and what it is not possible to do? This is all part of the holistic approach and all part of the DFMA approach. This is the most frustrating part of our job as designers. We think to do something, it is concept sketch, then we have the meeting with the client, but then on site, we see something completely different. I'm an engineer. I know there are many architects here, and we do not like to see this. We always want to prepare a drawing, and then to be sure that what we dreamed of will be on site. So why does it happen? Sergey said before, what you see is what you get. There was this acronym on his slide, but I prefer to change it to what you draw is what you get. Now in 2021, but it was already 6-7 years ago, now it is time to change this acronym and to change to what you draw is what you get. Why do I say that? Because if we use this concept, this approach, which is what you draw is what you get, we are sure that we prepare the concept sketch, we have the meeting with the client, and then we will have on site exactly what we wanted to have. It is nothing impossible. Of course, I'm talking, what I'm saying is about the structural elements. I cannot say about the finishings, about other things, but structurally speaking, we can be 100% sure that we will receive on site what was on our screen. It is exactly what happens when 3D printer. The only difference is that on 3D printers, we add materials. We start from scratch and we add new materials. With a CNC machine, with timber, we start from a bigger element and we remove the useless parts, the useless parts of the element. But all the process is always based on the digitization and is the workflow we use, and I suggest always also the other designers to use. The workflow is based on BIM technology, where we have all the drawing, we have the building, we have the information, and we can manage every single part of the project. A lot of people are talking about the digital twin when they talk about the smart cities. They say, we are happy to tell the world that we created the digital twin of the city. With timber industry, in the timber industry, it is nothing new. We've been using digital twin model for years. This means that we can share an IFC model with the client, with the architect. They can open the IFC model using Revit, ArchiCAD, Allplan, BIM Vision. There are many free IFC viewer, and you can click on an element and you see all the information related to that element. This means that if you click on the wall, the one highlighted in blue, you do not see just, it is a rectangle, that's it. You see that it is a CLT panel, it is 140 millimeters, the thickness, 15 meters long and 245 meters wide. It can also tell you the weight of the element you will see later, but you have all the information, 100 of the information are there on your screen, and then you are 100% sure that you will get that element on site exactly as it was in the IFC model. And this can happen 4, 6, 8 weeks before the assembly on site. No surprises on site. When I go to the site, mainly it's because I like to see how they work, I like to learn something new from the assemblers, but not to check if they are working in the right way. This can happen for walls, for beams, for connections. This is a building I'm going to show you later something more about this building. For the connections, we saw before beautiful connections made in Japan. Here we use the steel. There are some building codes, some problems because of the building codes to use pure timber connections. And here the client was allowed to check how the connection will look like on site. How many dowels, how big the steel plate, how it look after. Everyone can understand, this slide is taken from Matrix, from the movie Matrix. In that movie, they had like a digital twin world in digital format. So it is exactly the same thing. We, as timber engineers, we see the project not as a collection of beams, columns, walls, etc. We see the project as a huge amount of numbers, huge amount of data. So with this information, we can create this. This is how we see a CLT panel. It is of a project I will show you later. We have the possibility to check how the CNC machine will work. This is something taken very quickly in the office. And you can also see exactly, you can calculate exactly how many seconds the machine, how many hours the machine will take to machine the elements. And you can check also if there are clashes or if there are problems on the files for the CNC machine. When I was talking about augmented reality, I was talking about this. We implemented this technology quite recently during the summer. It was a long process. We worked for more than 1 year, 1.5 years. But this gives us the possibility to check how the connection, this is scale 1-to-1 connection. We're talking about 1.5 meters deep beam. And we can use this model. We're going to implement it in the HoloLens in the next few months. But we can check not only the connections, we can also analyze the structure and combine together with the results from the FEM software. So this means that we can explore the model, we can explore the digital model, and to see where we have concentration of stresses, where we could have problems, where and why we should increase the size of some elements. These are new technologies that can quite easily implemented, and since it is the one you're looking at, it is a digital twin of the model we will get of the building we will have on site, gives us the possibility to check every single part of the project, every single element, every single connection. So we can do this. The value engineering, thanks to these technologies, allows us to use some, what they call sometimes marginal gains, to use these marginal gains to reduce the cost, to make timber the most cost-effective material. And in this case, we compared on-site versus off-site. So for this building, we produced a company produced more than 700 elements. They pre-assembled some of them. So on-site, they assembled less than 300 elements. If you look on the corner up left, you see a stair. There is a ramp made of CLT, and then there are all the steps made of glulam. We're talking about 15 elements, more or less, 15, 16 elements, combined, pre-assembled together off-site, and then on-site is one single element. So it takes 20, 30 minutes for the assembly, more or less. In this way, we reduced a lot the time on site and consequently the cost for the assemblers. And this is another example, very recent. The company is going to assembly. This is a 6-story timber building in an Italian city, is Parma. We compared 2 different levels of optimization of the walls. On the left, the walls, we divided the walls in vertical elements. So we have 234 elements. But on the right side, we tried to reduce as much as possible the number of elements on site. So now we are talking about 192 elements. The surface is exactly the same because we're talking about 348 square meters, but we have 42 elements less. If you multiply by 6 levels, every element you need to consider that it takes about 20-25 minutes to be assembled on site. So if we multiply 20 minutes by 42 means 840 minutes, multiplied by 6 levels, we're talking about 5,000 minutes of extra time. So just working on the optimization, just working on reducing the number of the elements, we can reduce the assembly time by 5,000, approximately 5,000 minutes. This is an operation which is very important because in many cases companies use this as a basic unit to calculate to quote a price for the CLT. How many square meters are we talking about? Okay, 10 euros per square meter for the assembly. But what about if you have 192 elements or 234 elements? The difference is big. It means every minute means that you have 3 people, at least 3 assemblers, plus 1 crane. Multiplied by 20 minutes, by 5,000 minutes, it's a lot of time, a lot of money. Time is always money on site. So the softwares we are using like a ecosystem of software. This is nothing impossible. We are not talking about coding, about creating new software. We are more talking about integrating many software and getting the most out of each of them. So you recognize for sure some icons, and you associate the icon to the product. For freeform elements, we are basically using Rhino and Grasshopper to create the algorithms and then to create the files for the CNC machine at the very end of the process. So, said that, look at the time, I'm good. I'm showing you a few projects we worked on in the past years. This is a 6-story timber building. We are in Modena. In this area, we had a pretty strong earthquake in 2012. So people in that area now are more keen to live in a timber building. Generally in Italy we are very conservative. In some areas they are very focused on having stone buildings, building made of stone, concrete. So timber is not a very widely used material yet. Just to give you an idea, approximately 6% of the new buildings are made of timber in Italy, 5.5, 6.5% approximately. So we're not talking about huge numbers. But in this case, the client, the developer, decided to go for timber. We're talking about a 6-story building, and 6 people, as you see here, 6 carpenters, 6 assemblers, took just 6 weeks to assemble the whole timber structure. 1 floor per week. And we have about 2,400 square meters of CLT, not so much glulam, and we're talking about a surface, living surface, 1,300 square meters. The biggest challenge for this building was to find a producer that can produce and transport these huge CLT panels. We're talking about 2.5 times 15.5 meters. And you see here the digital twin on the left is approximately 2.8 tons. So instead of renting a huge crane for 6 weeks, we decided to go for a smaller crane and to have just for 8 hours a bigger crane for the day they had to install those elements. Those elements are the ones for the staircase, and they assembled. Probably it was 11, 12 hours, but they completed the assembly of the whole staircase of a 6-story building in just 1 day. And here you see the stairs. It's a very smart way to reuse the waste material, to reduce the waste, the percentage of waste material on site, and to, again, to reduce the cost. You don't have anymore to go as a designer, to go on site to draw the stair on the wall. You just receive the prefabricated elements, that's it. They install in 20 minutes, they installed one ramp, 20 minutes, another one, 20 minutes, the third one. So it is absolutely very, very fast. And precise at the same time, of course. On the left is the elevator shaft, completely made of timber, and on the right side it's me in front of the steel connections. We had to design custom steel connections to prevent the uplift of the building. So they are like 1.60 meters, more or less. And of course, a lot of screws. This is a floating structure. I was amazed yesterday when I visited in Rotterdam the building who was awarded yesterday before. We engineered this for the Biennale of Architecture in Venice in 2016. We had just 6 weeks to engineer the building, the pavilion, and to find a producer and to assemble it. To find a team of assemblers, go to Venice and assemble it, find a way to assemble the elements on the mainland, the building on the mainland, and then to transport to Venice on a barge. So you see here some details and some more drawings of the connections. This is another, well, second. I'll show you a bit more of the connections we decided to have for this building. And again, this was digital model, digital twin. It was exactly as it was on our screen. No surprises, no unexpected events, no chainsaw to use on site to correct the shape of the element. This is another very interesting building. It is the headquarters of an IT company based in Italy, but they sold the business to an American company. They are working on artificial intelligence for cars. So it's amazing what they do inside this building. And we had a very, very, very low budget. At the beginning of the first meeting we had with the owner, we said, no way, we can't make it. It is too low, the cost. You need to add at least 20%. Then he said, no, please, I want to have a timber building. Please find ways to reduce the cost. So we decided to leave the CLT exposed. We decided to have all the services going through the slab, and we engineered together with the company, with a producer, we engineered a new kind of slabs, ribbed slabs, made of CLT plus timber beams, plus glulam beams on the top. And here you see there is a hole, and almost all the services go through that hole. The hole, of course, was made off-site in the factory. 4 people, 4 weeks, completed the assembly of the structure. And again, digital twin, digital model, and the real building at the end. Another project is this one, is a volumetric modular building. It is located in Trondheim, in Norway. And we engineered a complex of 4 condos in total. These are the biggest, the tallest volumetric modular building hybrid, they said, because we have a central core made of concrete, which is 10 by 10 meters, and then around they used volumetric modules purely made of timber, the structure, as you will see in a few seconds an animation. What is incredible is that for an 8-story building of about 4,000 square meters, they took just 13 working days to complete the assembly. And this is the way they work. The one in the middle is the central core made of concrete, and then around there are many volumetric modules. We have about 110, 115, it depends. There were 4 buildings, so it was between 110 and 120 modules. When we had the meeting with the company, they said that they can assemble more than 10 modules per day. I was very skeptical. I was quite almost laughing. I said, come on, it's impossible. But then they proved they made it. The buildings are there, and it worked very, very well. This is the FEM model, and this is the building completed. You can not, nobody can say that this is a modular building, this is a timber building. You don't see anything from outside. This is the last project, the last 3-4 slides. We're talking about super hybrid building because the main structure is made of concrete and steel. But then when it comes to think about how to realize the facade, the architects were very worried because they couldn't find a cheap, cost-effective way to realize it and to be sure that they will have all the windows, all the openings exactly as they were in the Rhino model. So, because all the openings have a specific meaning, it's like a pixel effect. They can change the color of each window, so they can change the color of the facade or have the flag of a country the visitors come from. So they wanted to have this, exactly this effect, and we had a few meetings, and CLT proved to be the best material in this case. So as you see on the left, there are steel columns, and then there are the CLT elements. This is the digital model. We had to work a lot with them to import, export the file, to understand the language of the CNC machines. But yeah, the most exciting part was that there were 3 different engineering firms working together and exchanging digital files. We used IFC format to exchange the file, but there was 1 team for concrete, 1 team for steel, and 1 team for timber. And it worked very well. All the files were on a cloud system, and everyone could take the file, import in his model, check if everything was okay, and then create the files for the CNC machine. Also, the image you see is taken from BeamVision, a very nice IFC viewer, which is for free, fortunately. You click on the element, and you see all the information. For instance, here it is written C24, which means the timber grade. 34 is the assembly number. So the assembly drawings are, you can see the number of each element you have to assembly, number 34, 33, 45, etc. So it is like, I like to say, it is like having IKEA furniture to assemble all the elements together until you have the final result. So, a bit late. Thank you.